and we are going to be looking at a complex or ternary ionic compound with a transition or a poor metal. And our example is going to be FeCO₃. I see three elements in this. I see the Fe, I see the C, and I see the O. So this is definitely not a binary ionic because I've got more than just two atoms in it. So I'm going to be looking for a polyatomic ion. And I see right away that CO3, the anion part of this, is a polyatomic ion that we should recognize because it is on our list here of polyatomic ions. And the cation Fe is on our periodic table right here. So it is a monatomic ion. So I know that I've got a complex ionic compound because this is composed of at least one or more polyatomic ions. So step one is to capitalize and name the cation. And that's pretty easy because Fe just stands for iron. Step two, if the cation is a transition or a poor metal, I have to add a Roman numeral in parentheses to show how many valence electrons it has. And this is where things get a little bit more tricky. And we have a cat attack. So I'm going to have to do a little bit of detective work on this one. I've got to figure out what the charge for the iron was. In other words, I need to uncriss-cross and unreduce this chemical formula. So it's a 1-to-1 ratio of ions, right? Because I haven't added parentheses around the polyatomic ion and the Fe doesn't have any subscript. So I'm going to go back and just temporarily, I'm going to put in that 1-to-1 ratio. And I'm also going to go and look up the charge of carbonate because that's on my list here of polyatomic ions. And the charge it says, that's my cat Ozzy, the charge it says for carbonate is a 2- charge. So I added in that 2- charge just for now because we're kind of working backwards. So if I uncriss-cross, the 2- became a 1. So what was the charge for Fe that had to become a 1? Well, it still has to be a 1-to-1 ratio. So maybe you figured it out by now, but it has to be a 2+. That way, when you crisscross the 2 and the 2, they reduce to 1 and 1. And that's the only possible charge for the iron. So that means that the iron had to have 2 valence electrons. Metals always give away all their valence electrons. So if the charge was a 2+, that means it gave away 2 valence electrons. So I need to tell somebody when I name the iron, I need to say, here is how many valence electrons the iron atom had before it transferred those electrons to the carbonate. And these transition and poor metals have this weird ability where they can promote electrons to their outer energy level and then they give them away. So you have to say how many valence electrons were there. And we've done that now. We've given it the Roman numeral. Okay, let's name our other ion. That one's easy because I just name it exactly like it is on my list here of polyatomic ions. And you'll always just scroll down the list and you'll find carbonate. It is almost down at the bottom there. Carbonate. And I just name it exactly like it appears. I can never ever change the names of those polyatomic ions. So my final answer is iron 2 carbonate. And that is how you do nomenclature for ternary or complex ionic compounds when they have a transition or a poor metal in them. Thanks so much for joining me.